Hello everyone, welcome back to Jom Studylah channel. Let's continue with our lesson for IGCSE Chemistry Chapter 3 Part 2, Elements and Compounds. Before further ado, let's look into our study outline. Our study outline comprises of the periodic table, noble gases, formation of chemical bond, formation of ionic bond, chlorine atom, formation of positive ion and negative ions, and finally, covalent bonds. From the previous chapter, we already studied about the periodic table. Let's recall it. A group is a vertical column in the periodic table. Groups are family of elements. The members of the family are similar but not exactly the same. There are 5 main groups in the periodic table. All the elements in the group have almost the same chemical properties, but they differ slightly in the physical properties. Group 1 is called alkaline metal group. Group 2 is called alkaline earth metal. Group 17 is called halogen group. And group 18 is called noble gas. And the biggest group of element is called the transition metals group. And it lies between group 2 and group 3. Let's go to the quiz. For the question number 1, with reference to the periodic table, sodium is a mixture, elements or compound. And question 2, sodium chloride is a mixture, element or compound. Please leave your answers in the comment section below. Let's look into noble gases. Noble gases is any of gases element, helium, neon, argon, krypton, xenon, radon, occupying group 18 of the periodic table. Usually, this group exhibit great stability and extremely low reaction rates. Let's look into further details about noble gases property. The noble gases are stable because their outmost shells are full. Their full shells are stable because they have 2 electron duplet configurations such as helium atoms, 8 electron octet configurations such as in all the octet noble gas atoms. The atoms of noble gases do not donate or give away electrons from their atoms. They do not form positive ion. They do not receive electron in their electron structure. Do not form negative ions. Example, argon does not donate electron. Argon does not form positive ion. Example, neon does not receive electron to form negative ion. The atom of noble gases find it difficult to form compounds, difficult to form positive and negative ion, formation of positive and negative ions to form ionic compounds. They share electron in their electron structure to form covalent compounds. In general, with few exceptions, atoms of noble gases do not form ionic or covalent compound. Let's look into formation of chemical bond. Chemical bond is a lasting attraction between atoms, ions, and molecules that enables the formation of chemical compound. Chemical bond can only be formed if there is a transfer of electron from one atom to another atom, or there is a sharing electrons. During the transfer of electron, positive ion and negative ions are formed. The compound formed by combination of positive and negative ion called ionic compounds. So in the sharing of electron, covalent compounds will be found. Except for atom noble gases, all other types of atom do not have stable electron configuration due to no octet or duplet configuration of electron. Example, sodium and chlorine atoms do not have complete outer shells of electron. Sodium can react with chlorine to form sodium chloride. Example given in the chemical reaction below, sodium plus chlorine to produce sodium chloride. During the reaction, sodium achieves a complete outer shell by donating electron, whereas chlorine achieves complete outer shell by accepting electron from sodium atom. So there are two main types of bond. One is ionic bond and the other one is a covalent bond. Let's look into formation of ionic bond. Formation of ionic bond is also called electrovalent bond. Type of linkage formed from electrostatic attraction between opposite charged ion in a chemical compound, such as bond formed when valence outermost of one atom transferred permanently to another atom. In this example, we look at the sodium atom. The sodium atom has 11 electrons and its configuration is 2.8.1. The electronic configuration is not stable, does not have octet configuration of noble gas element. It can obtain octet configuration by giving away its valent electron to become positive ion. So originally, sodium atom having the electronic configuration of 2.8.1 and it has become stable by losing an electron and attaining electronic configuration of 2.8, which is stable. If you can see from the diagram, so one electron removed. So it becomes 2.8 in the electronic configuration by losing an electron. Let's look into the chlorine atom. A chlorine atom has 17 electrons and its configuration is 2.8.7 as shown in the diagram A. And the electronic configuration is not stable, does not have octet configuration of noble gas elements. It can obtain octet configuration by gaining one electron to become negative ion. So, refer to the diagram B, the electron structure of chlorine atom after gaining an electron to become a chloride ion. You can see the actual chlorine electronic configuration is 2.8.7. So it becomes stable by gaining an electron and achieving electronic configuration of 2.8.8. So when sodium atom react with chlorine atom, an electron of sodium atom is given to the chlorine atom in the diagram C as shown on the right hand side. So after sodium atom has given its electron to chlorine atom, the number of electron and proton in both atoms are not balanced. Original sodium atom has 11 proton, 11 electron, and net charge is 0. But after losing one electron, it consists of 11 proton, 10 electrons, and net charge equals to 1, positive 1. So in this way, positive ion sodium is performed. After chlorine atom has received the electron, its charge are not balanced. Original chlorine atom has 17 proton and 17 electron. Net charge is 0. After receiving one electron, it consists of 7 proton and 18 electron, and the net charge is -1. So in this way, a negative ion is performed. Negative ion chlorine is performed. So the negative charge ion, sodium, will attract negatively charged ion chlorine to form compound natrium chloride. This force of attraction enables two ions to stick together. So as a result, this produces ionic bond between two ions. Let's look into formation of positive ion and negative ion. Metal atom lose electron to form positive ion. On the other hand, non-metal atom gain electrons to form negative charge ion. Let's look the example on the positive charge ions. All elements in group 1 of the periodic table have one valence electron. All the elements can lose this electron to achieve the electronic configuration of the noble gas atom. After losing the electron, they will form positive ion with the charge of 1 positive. Example given here is lithium. Lithium, the electronic configuration is 2.1. But after losing the electron, they form positive ion with the charge of 1 positive. So the electronic configuration for lithium now become 2. And 2 is actually, they carry the helium electronic configuration structure. Same thing goes to natrium or sodium. Sodium, the electronic configuration is 2.8.1. So after losing the electron, they will form positive ion with a charge of 1 positive. So now sodium carry positive. So it's carried the electronic configuration of 2.8. 2.8 is actually the neon structure. And looks into the magnesium. Magnesium, all atoms of the elements in the group 2 of the periodic table have two valence electrons in their outer shell, which is each atom can lose these two electrons to form an ion with a charge of 2 positive. So by doing this, they can achieve the electronic structure of the atom of the inert gases. Example, magnesium. The initial electronic configuration is 2.8.2, but after losing these two electrons, they form an ion with a charge of 2 positive. You can see magnesium 2 positive, which is 2 having the electronic configuration is 2.8. 2.8 is actually neon structure. And it's the same thing goes to aluminium. Aluminium atom of the elements in group 13 of the periodic table have 3 valence electrons in their outer shells. Each atom can lose these 3 electrons to form an ion with a charge 3 positive. By doing this, they can achieve the electronic structure of the atom of a noble gases. Initial electronic configuration for aluminium is 2.8.3, but after losing 3 electrons to form an ion with the charge 3 positive, now aluminium become aluminium 3 positive, which is it carry the electronic structure of 2.8, which is neon structure. Let's look into the negative ions, where non-metal atom gain electron to form negative charge ion. All atoms of the elements in group 17 have 7 electrons in their outermost shells. The elements in group 17 can achieve the electronic structure of the atom of the noble gas by receiving an electron each. In this process, they form negative ion with a charge of 1 negative. Let's look into this example. F receiving an electron, 1 electron, and it becomes F with a charge of 1 negative. So, it's carried the electronic configuration structure 2.8. So 2.8 is actually referring to neon structure. And let's look into the oxygen. All atoms of all elements in group 16 of the periodic table have 6 electrons in their outermost shell. They can achieve the electronic structure of the atom of a noble gas by receiving 2 electrons each. In this process, they form negative ions with a charge 2 negative. Example, initial configuration, electronic configuration for oxygen is 2.6, but by receiving 2 electrons each, it becomes oxygen 2 negative with a charge of 2 negative. And then the electronic configurations for oxygen 2 negative will be 2.8. So it's also carry a neon structure. And finally, nitrogen is in group 15 of the periodic table. It has 5 electrons in the outermost shell, and it can achieve the octet configuration by accepting 3 electrons. Example, for the nitrogen, the electronic configurations for nitrogen is 2.5, but after accepting 3 electrons, it becomes nitrogen with the 3 negative, and it's actually the electronic configuration structure is 2.8. So also it's carry neon structure. Let's look into the covalent bonds. Covalent bonds is a chemical bond that involve the sharing of electrons to form electron pairs between atoms. So let's look into the detailed properties of covalent bonds. A bond formed by sharing a pair of electrons between two atoms. A bond formed between non-metal atoms by sharing of electrons. Non-metal like hydrogen, carbon, and oxygen do not lose electron from their outer shell. They do not form positive ion by losing electron, but their outer shells is incomplete. Electron needs to be added to the outer shells to attain stability of noble gas atom. When the atom of two non-metal react, all the atoms need to gain electron to complete the octet shells of electron. They do this by sharing electron between them. A covalent bond between two hydrogen atoms in a hydrogen molecule, a single covalent bond, is shown by a line between the two atoms. So the shared electron in the covalent bond usually come from the outer shell of the atom, which combine. And when some non-metal atoms combine, not all electrons in the outer shell form covalent bond. The pair of electrons not used in covalent bonding are called ion pairs. Ion pairs is a pair of electrons in the outer shell of an atom in a molecule which does not form a covalent bond. And some atoms are able to share two pairs of electrons to form a double bond, example given like oxygen. And this is actually a summarization of what I already emphasized in the previous slide, and just go through a little bit. And there is some additional about the properties about the covalent compounds and ionic compounds. So, formation of chemical bond or bonding and structure. Chemical bond can only be formed if there is a transfer of electron from one atom to another, or there is a sharing of electron. And during the transfer of electron, positive ion and negative ion are formed. So the compound formed by the combination of positive and negative ion are called ionic compound. So in the sharing of electron, covalent compound also will be formed. So let's look into the ionic compound where the properties have a strong electrostatic attraction between the positive and negative ion, high melting and boiling points, and conduct electricity in aqueous solution and in the molten state not soluble in organic solvent. Some are soluble in water. Whereas in the sharing of electron, you can see in the sharing of electron, covalent compound will be formed. So the properties of the covalent compounds is they have a strong intramolecular bond, weak intermolecular attraction, low boiling and melting points for simple molecular compounds, and do not conduct electricity generally, not soluble in water but soluble in organic solvent. With that being said, I would like to thank you very much and also to wish you all the best in your study. Hope you are clear with the presentation of the subject matter. You can get the detailed or customized note by clicking Jom Studyla Instagram. And finally, last but not least, please press the thumbs up like button, subscribe to Jom Studyla YouTube channel, and follow me at Jom Studyla Instagram. Thank you very much.